Greetings. If you recall in the last video, we created some socket code for the server side, which will listen on port 12345, and we have it running on Linux Lab machine UW1 32006. And it's just waiting there in the accept call, lonely, waiting for a client to connect. So let's build some code and see if we can connect with that server code over TCP/IP. Here's the client code. Again, this is out on campus. You can download it. I have a bunch of .h files here because we'll be using the socket calls that come with Linux. I have a buff size of 1500 bytes. That's the size of the buffer that the client's going to create and send over to the server. The server's going to read that buffer, remember, change that 13th byte, and write it back to the client. The port we're going to use is 12345. That's where the server's listening right now. So I have port 12345 set there. Let's go ahead and start. I pass the server name in on the command line. So as argv1, we'll get the server name. And then I call this get host by name with that server name. This is a system call on Linux which returns a host ent struct. And the host ent struct has interesting things about the address of the server, or the address of the name that you pass in. So I get back this pointer to the host ent struct, and from that I can create the socket address. Let's look at this code. I create a sock address in structure. The next line I zero it out. I set the SYN family to AFINET, saying I'm going to use the internet. And then I dig into the host ent structure that was returned, that host structure. I pull out the H address list. This H address list is the IP address of the host that I passed in. I do this inet n to a to put it in the right format, and I set the SYN address S address to that value. Basically what this line is doing is it's setting up the socket address so that it points to the server name that I passed in. On the next line, I set the port, the SYN port on that socket address. So now I have an address structure which has the IP of the server that I want to connect to and the port number that I want to connect to. And as you know, a socket is an IP address and a port. With that done, we can go ahead and try to connect. I will go ahead and create a socket. AFINET is passed in because it's the internet, and I'm using SockStream, so I'm using TCP/IP. What gets returned is an index into the file descriptor table, that index into a location which points to the socket. So now I've created a socket. I can now use that socket to directly connect to the address that I created above. And I do that with the connect system call. So here I am connecting to the client socket descriptor that I got back from the socket I created, and I'm passing in the address that I want to connect to. This is the address that I created above that has the port number and the IP address of the server. Now I've connected. On the server side, at this point in time, the accept has accepted that socket. It has created a new socket in return from the accept, and the server now has a connection to the client. Let's have the client write to the socket and then read from the socket. I'll create a buffer that I want to write into the socket of buff size, and I just fill it in with Z's. And then I go ahead and I write to the socket. I'm writing to that socket descriptor, the data buff, and the buff size. Again, the write and read code looks exactly like you would to a file system. This is one of the beauties of Linux. Reads and writes to devices all look the same, whether it be a file, a pipe, a socket. Now that I've written the bytes to the socket, I would like to read from the socket itself. Recall the server reads in the bytes, changes that 13th byte, and writes it back. And so I do a read, just like you'd expect, on that socket. reading into the same data buff that we created of 1500 bytes. Then, just to make sure that I actually got back the data from the server, I go ahead and print out that 13th byte. When I'm done, I close the client socket. And that's that. I've created an address, created a socket, connected to the server, wrote some bits, read some bits. I went ahead and copied that client code over to the Linux lab. In this case, I am on machine UW1-32007. As you can see, there's the client code. Let's go ahead and build that client code. It looks like it built fine. Now we are going to go ahead and run the client code. If you recall, the server is still waiting to be connected to. We'll run the client. Oh, I need to pass in the server name, UW1-320. The server happens to be on 06. Looks like it ran fine. The host name that it connected to was UW1-32006 uwb.edu. It pulled that from that host ent structure that we grabbed. It used socket number 3 in the file descriptor table. It wrote 1500 bytes, it read 1500 bytes, and notice on the client side, we got that R back from the server. Let's look at the server code. The server accepted the socket. In this case, it used file descriptor number 4. It read 1500 bytes. That first byte was a Z, and then it wrote 1500 bytes. Closed both the sockets, the one it was accepting on as well as the client socket. In our program 4, you'll be writing code very similar to this. Not quite the same, but very similar. Feel free to download the code that I have written and start from there. Thank you.